Okay, we have to solve for a variable first. And so in that top equation, you have negative 2x plus y equals negative 6. I'm going to add 2x to both sides. And then I have y isolated. And I can plug this into both of the other equations and solve for all three variables. So first I'm going to plug it into the second equation, which is 4x. And that's 4x minus 3y minus 2z equals 14. Now I'm going to plug this into this y. So that's 4x minus 3 times 2x minus 6 minus 2z equals 14. And I'm going to distribute that. That would be 4x minus 6x plus 18 minus 2z, and it equals 14. I'm going to subtract 18 to put it on the other side. So that's minus 18. And you have, I'm going to combine these two, so you have negative 2x, the 18's go away, minus 2z equals negative 4. And this is one of the two equations that we're trying to get to. So I'm going to come over here and plug y equals into the next one. So the last equation is negative x plus 2y, but I'm not putting y, I'm putting what it equals. And that would be 2x minus 6 minus 3z equals 12. Okay, let's distribute that 2 into the parentheses, and that would be negative x plus 4x minus 12 minus 3z equals 12. I'm going to add 12 to both sides and combine these x's. Negative x plus 4x is 3x. The 12's go away. Minus 3z equals 24. Okay, there's the other equation that we're going to use. And I'm going to reduce both of these equations because it just makes them easier to deal with. The first one, the green one, let's go back over there and I'll reduce it underneath that. If I divide everything in here by negative 2, it's like reducing an equation, but in this case it's like reducing fractions, but in this case it's reducing the equation. So it's x plus z equals 2. And there's one equation reduced. I'm going to do the same thing over here, except I'm dividing every term by 3. And you end up with x minus z equals 8. And that would, these are perfect equations for elimination right here, but since we're doing substitution, I'm going to substitute it. And I'm going to take this second equation and I'm going to add z to both sides, and we're going to have x equals z plus 8, and I'm going to substitute this in to that equation. So let's come over here, and I'm going to rewrite that x plus z So, but I'm not putting x. I know it is z plus 8 plus z equals 2. And so that's 2z plus 8 is 2. Subtract 8 from both sides, and you have 2z equals negative 6. Divide both sides by 2. Z is negative 3. Okay, I'm going to plug that in to x plus z equals 2. And I'm plugging it into a green one, so I'm going to write it in green. And that's x plus a negative 3 equals 2. Add 3 to both sides. X equals 5. Okay, so we have x and z. We need y, and so I'm going to plug that back into the very first equation that I came up with, and that's in blue, so I'm going to plug it back into there. And that is y equals 2x, but that's 2 times 5, minus 6. Y equals 10 minus 6. Y equals 4. Okay, and I'm going to write that as an ordered pair, and I'm going to move back over here where there's a little bit of space. So that would be, I'm going to put this in blue. 5, 4, negative 3. And there's your answer. And let's draw a line. There we go.